Recently, an Indian state leader placed a massive bounty on the past, $1 million to anyone who can decode a 4,500-year-old script. Looking at the extensive mud brick ruins of Mohenjo-Daro, you can see the footprint of a Bronze Age powerhouse. The Indus Valley civilization spanned an area that dwarfed contemporary Egypt and Mesopotamia, featuring gridded streets, complex plumbing, and standardized brick sizes across a massive geographic area. Yet, for all their architectural scale, they left us with absolute silence. We do not know the name of a single ruler, a single deity, or a single citizen who walked those streets. What we do have is their writing. Carved right above animal motifs like this unicorn figure, we find clear, precise pictographic characters. Archaeologists have recovered over 4,000 objects stamped with these exact kinds of symbols. Over the last century, brilliant minds from around the world have published more than 100 claimed decipherments. Every single one of them has failed to gain universal acceptance. The code remains entirely unbroken. Cracking this script would redefine our understanding of the ancient world. But researchers are struggling because of how the Harappans chose to record their information. This is the Rosetta Stone. The distinct three-tiered registers you see here provided epigraphers with a known language, Greek, to anchor the unknown Egyptian hieroglyphs. To translate a dead script, you need either a bilingual text like this or a known linguistic descendant to trace backward. Anyone trying to analyze the Indus Valley Script has 0 bilingual texts to work with and no verified linguistic descendant to trace backward. But the deeper problem is the physical data. The surviving Indus inscriptions are shockingly brief. Out of those 4,000 objects, the text strings average just 4.6 signs. You can see the contrast directly in this image. On the bottom is Egyptian pottery covered in dense paragraph-length hieratic text. On the top is an Indus sherd. Other ancient societies used scrap clay to write long messages. The Harappans barely scratched a few symbols. In fact, the absolute longest continuous string of symbols ever found on a single Indus surface contains only 17 signs. Without paragraph-length texts, traditional epigraphers are starved of data. They simply do not have enough characters to identify the repeating grammatical patterns you need to identify a real language. This data deficit led 3 researchers to publish a paper in 2004 that asked a radical question. What if the people of the Indus Valley couldn't read or write at all? They pointed to a specific quirk of phonetic languages. When humans write down spoken words, we constantly repeat letters and syllables within a single sentence. Think about how many times the letter E appears in an average English phrase. Now, look at this layout of the longest known Indus text. 17 signs in a row, and not a single symbol repeats. Every shape is entirely unique. Expand that out to the entire known library of 400 Indus signs, and an even stranger pattern emerges. Exactly half of these symbols appear only a single time in the entire historical record. These are called singletons. Civilizations do not invent a specific character just to use it exactly once in their entire history and never again. The researchers concluded that we've been staring at non-linguistic symbols. They argued these marks functioned like family crests, heraldry, or religious badges, identifying clans and deities, rather than encoded speech. For these researchers, brevity is the primary evidence that the largest Bronze Age civilization on Earth was entirely illiterate. Modern computational linguists refused to accept that conclusion, and they brought heavy mathematical artillery to prove the skeptics wrong. Researchers took all those thousands of tiny, fragmented text strings and fed them into machine learning algorithms to measure something called conditional entropy. Conditional entropy is simply a statistical measure of predictability. In English, if you see the letter Q, you can predict with near certainty that a U will follow. True languages have a very specific, measurable rhythm of predictability. This chart visualizes the algorithm's results. The Indus symbols plot perfectly alongside the curves of known spoken languages like Sumerian and English. The data sharply diverges from the paths made by random, non-linguistic symbols. Even in short 5-character bursts, the algorithm showed the symbols adhere to strict internal grammatical rules. They are not random crests, they follow an order. We might not be able to read the words, but artificial intelligence has confirmed the script possesses the mathematical heartbeat of a true language. The debate remains locked in the standoff. Until archaeologists find a translation tablet or a massive paragraph-length text, neither side can definitively win. If the computational linguists are right, cracking the code would expose the deep roots of South Asian language families. It would finally return a voice to a silent empire. But if the skeptics are right, we have to face an entirely different reality about human advancement. It would mean a society successfully managed unparalleled urban planning, complex plumbing, and centuries of cultural unity across a massive continent, all without ever writing down a single word. Whether these symbols represent a lost language or a symbolic illusion, the Indus Valley Script forces us to rethink what it actually takes to build a world power. Around 1800 BC, the island of Crete emerged as a dominant maritime power, becoming the earliest society in Europe to organize into complex urban centers. The Minoans left behind a vast architectural footprint. They constructed sprawling complexes with multi-story buildings, vibrant frescoes, and distinct red-pillared architecture. But while their buildings survive, their voices do not. To manage their vast economy, the Minoans developed a writing system we now call Linear A. This is a surviving clay tablet inscribed with Linear A. It is one of over 1,400 remaining artifacts, and the finely pressed rows of abstract characters reveal their primary purpose: administrative record-keeping and ancient bookkeeping. So we have a civilization that produced a mountain of paperwork, yet thousands of years later, we cannot read a single sentence. The Minoan voice remains entirely trapped in clay. The primary hurdle preventing translation is that linguists classify Minoan as a language isolate. It has no known linguistic relatives, living or dead. There is no baseline vocabulary or grammatical structure to compare it against. To make matters worse, researchers have never uncovered a bilingual text, like a Rosetta Stone, that places Linear A side by side with a known language like Egyptian hieroglyphs. Without a parallel text or a related tongue, traditional methods hit a dead end. To read these tablets, researchers had to find an entirely different methodological path into the script. Researchers looked toward Linear B, a script that evolved directly from Linear A centuries later. In 1952, Michael Ventris proved that Linear B was used to encode an early form of Mycenaean Greek. Look at this comparison. The two systems are nearly identical, sharing approximately 70% of their signs. Because we know how to pronounce Mycenaean Greek, researchers tried a substitution, plugging the known sounds of Linear B into the matching symbols of Linear A. This creates a theoretical bridge. Suddenly, previously silent symbols yield readable, pronounced syllables. To test if these sounds actually meant anything, linguists turn to toponyms, place names. Cities and geographical features rarely change their names, even when a new civilization moves in. This map shows researchers hunting for distinct symbol clusters on tablets across ancient Crete. Applying the Linear B phonetic substitution to these clusters makes recognizable locations emerge. For instance, the sign cluster Paito corresponds to the city of Phaistos. By successfully transcribing these place names, scholars can analyze the words using the rules of historical phonetics. Some proponents analyze these reconstructed roots and trace them directly to ancient Indo-European languages, specifically Anatolian tongues like Luwian or Hittite. The logic follows that if these Minoan cities have distinct Indo-European names, the underlying language isolate recorded on these tablets might actually be a member of the Indo-European family. There is, however, a critical flaw at the center of this methodology. Just because two languages share the same written script does not guarantee they share the exact same phonetic rules or vowel structures. If you try to read a completely foreign language using English phonetic rules, simply because it also uses the Latin alphabet, you will end up pronouncing absolute gibberish. The Mycenaeans likely adapted the Minoan script to fit their own language, meaning the sounds might not match one-to-one. Because of this methodological blind spot, there is fierce academic pushback against the Indo-European hypothesis. Look at this breakdown of competing theories. Other scholars have applied similar analytical methods to the exact same texts and concluded that Linear A is a Semitic language, or belongs to the Tercinian family, alongside Etruscan. Some researchers have even run statistical analyses to suggest connections to the Uralic language family. Without definitive proof, Linear A has become a linguistic Rorschach test. Researchers apply their own phonetic interpretations and find the exact language family they set out to look for. Until the discovery of a bilingual text provides a definitive translation, the study of these ancient place names remains our best tool. Even if we cannot yet hear the Minoan speak, tracing their steps brings us closer to mapping the linguistic ghosts of the Mediterranean. This appears to be a standard relic from the late Middle Ages. It has the rough, fibrous texture of animal skin parchment, bound together with typical iron gall ink. However, the familiarity quickly disappears upon closer inspection. The pages are filled with illustrations of flora that do not exist in the natural world. This specific drawing features a sprawling, unrecognizable flower with distinct red stripes. Curious. The strangeness spans across hundreds of pages, from massive twisting root structures to surreal biological diagrams featuring naked women in green baths. Surrounding these surreal illustrations is a dense, looping script. The manuscript contains roughly 38,000 words, written consistently from left to right with clear paragraph divisions. Yet, in the 6 centuries since the ink dried on this parchment, no human being has been able to read a single word of it. The codex functions as a perfect lockbox, creating a tension between the promise of lost medieval knowledge and the potential of an elaborate historical prank. The modern history of the text begins in 1912, when it was rediscovered quietly resting among a collection of hidden books at the Villa Mondragone, a Jesuit retreat outside of Rome. It was purchased there by an antiquarian book dealer named Wilfrid Voynich. He saw an ugly duckling among the illuminated manuscripts and brought it to the world's attention. Voynich shared copies of the manuscript with the scientific community, triggering a century of intense cryptological scrutiny. The challenge eventually attracted elite military codebreakers, people like William Friedman, whose teams successfully cracked complex enemy communications during the World Wars. They applied their most advanced decryption techniques to the book and failed completely. The total collapse of these professional efforts leaves the Voynich manuscript as an active, undefeated scientific enigma. To solve a cold case like this, researchers have turned to the scientific method to rule out the possibility of a modern forgery. A 2009 radiocarbon test of the calfskin vellum firmly placed the parchment's creation between 1404 and 1438. Separate chemical analysis of the pigments reinforces this. The iron gall ink and ground mineral paints align perfectly with recipes typical of 15th century Europe. The physical evidence is definitive. Wilfrid Voynich did not forge this document. It is an authentic artifact from the early 1400s. We can trace the book's chain of custody backward from its current home at Yale University, through the Jesuit archives in Italy, all the way back to 17th century Prague. Records show the Holy Roman Emperor, Rudolf II, purchased the manuscript for 600 gold ducats. He acquired it under the mistaken belief that it was the work of the 13th century philosopher Roger Bacon. The text then passed to Bohemian alchemists, who sent copies of the pages to famed polymaths like Athanasius Kircher. Even the sharpest scholars of the 1600s were completely baffled by the characters. Since the greatest minds of the 1600s couldn't read it, the manuscript was a profound mystery centuries before modern science, eliminating suspects like Roger Bacon. With physical forgery ruled out, the investigation turns to the statistical data hidden within the Voynich script itself. This chart displays Zipf's law, showing how words naturally distribute in languages. When researchers map the words in the Voynich manuscript, the data points align perfectly with this descending curve. This statistical alignment eliminates the theory of random, unthinking gibberish. This bar chart compares the character frequencies of Voynichese against known European languages from the same era. The distributions severely mismatch, ruling out the possibility of a simple substitution cipher. We are left with only 3 complex options: a highly advanced unbreakable cipher, a completely undocumented constructed language, or a mathematically flawless medieval hoax. The undeniable reality of this cold case is a 600-year-old Alpine codex crafted by multiple scribes for a purpose that has evaporated from human memory. We live in an era where artificial intelligence and supercomputers process oceans of data in milliseconds. We expect to decode and classify everything. Yet when we point our most advanced pattern recognition technologies at this 15th century parchment, they can only stare blankly at the puzzle. The manuscript establishes a definitive boundary for modern discovery, proving that human history still contains mysteries capable of surviving beyond the reach of our technology. Around 1300 BC, the Mediterranean was defined by monumental architecture and urban centers. These stone lions guarding the Gate of Mycenae represented the peak of a sophisticated, highly organized society. Power was concentrated in a club of 4 great empires: the Mycenaeans in Greece, the Hittites in Anatolia, the Egyptians, and the Babylonians. They shared a vast, interconnected landscape. These empires functioned on bronze. To produce it, they had to import and combine copper and tin from distant regions. Cyprus served as the Mediterranean's central hub, shipping massive quantities of copper across every border. Sourcing tin required even more effort. This map traces trade routes extending 1,800 miles east to reach tin deposits in Afghanistan, proof of a logistics network that operated on a global scale. Diplomacy, royal marriages, and trade bound these distant powers into a single economic system. They built an age of shared prosperity where no nation was truly isolated. Between 1200 and 1150 BC, this entire system vanished. Progress that took centuries to build disappeared in a matter of decades. Archaeologists have found evidence of total destruction. From Greece to Gaza, almost every major city was burned and abandoned. These ruins are all that remain of the great temple of Hattusa, the once mighty Hittite capital. The collapse was so severe that complex administrative writing systems, like the linear B script on this clay tablet, simply vanished. The survivors stopped keeping records. Egyptian records at Medinet Hablou provide a name for the perceived cause: the Sea Peoples. This relief shows these marauding invaders clashing with the pharaoh's chariot archers. While these invaders were once the primary suspects, modern research suggests the collapse resulted from a more complex failure. The destruction of these interdependent kingdoms raises questions about the long-term stability of any highly connected world. Researchers use ice core samples to measure fluctuations in the ancient atmosphere. Around 1200 BC, the data indicates the region entered a 300-year megadrought. As rainfall dropped, crop yields failed across the Mediterranean. Starvation began to destabilize the social order of the major cities. At the same time, the region was hit by earthquake storms, a series of major seismic events occurring in rapid succession along the fault lines. These earthquakes leveled infrastructure in critical economic hubs. The collapsed stone walls here in Ugarit show the physical destruction that hit these cities while they were already struggling to find food. These compounded disasters stripped empires of their foundational resources. Food and shelter became scarce, weakening the central administrations. These groups traveled with their families and possessions across a barren, dusty landscape. They arrived as refugees, displaced by the failing environment in their homelands. Faced with famine and destroyed cities, they turned to raiding and migration to survive. They pushed toward the remaining stable territories in search of land. The sheer volume of these displaced populations overwhelmed local defenses. This carving at Medinet Habu depicts the violent result, as the remaining empires fought to repel the waves of migrants. This evidence suggests the invaders were a violent symptom of the changing climate, adding a secondary stressor to an already fragile world. The mechanism that turned these individual disasters into a total collapse was the trade network itself. A drought in Anatolia led to famine and internal rebellion, causing the Hittite administration to fail. This localized failure severed the trade lines. The Hittites stopped exporting the goods that other nations relied on to survive. Without these imports, nations like the Mycenaeans lost access to copper and tin needed for bronze. Their military strength evaporated just as the waves of migrants arrived at their borders. Because these nations were so dependent on one another, the collapse of a single state triggered a cascading failure across the entire system. The aftermath was a centuries-long dark age. Palaces lay in rubble, populations declined, and international trade lines were severed. Survivors were forced to adapt. Without a reliable supply of imported tin, they began to work with a harder, locally available metal, iron. This period of reorganization eventually allowed for the rise of the Phoenicians and the city-states of classical Greece. New societies were built on the ruins of the old. The collapse of 1177 BC stands as a warning. It demonstrates that complex, globalized systems can be incredibly fragile, and the very connections that enable their growth can also accelerate their downfall. On October 13, 1917, 70,000 people stood shivering in a muddy Portuguese pasture. Torrential rain had been falling all morning. Gathered among the peasants and the faithful were strict secularists and hostile government officials, including Avelino de Almeida, the chief editor of Lisbon's prominent anti-Catholic newspaper. Then, right around noon, the rain finally stopped. The heavy clouds parted. The crowd watched as the sun appeared as a dull silver disk that did not hurt their eyes. And then, according to tens of thousands of witnesses, it began to spin and zigzag across the sky. Almeida himself published his eyewitness account in his paper, O Seculo. He wrote, "Before the astonished eyes of the crowd, the sun trembled, made sudden incredible movements outside all cosmic laws. The sun danced according to the typical expression of the people." Why would tens of thousands of people, including die-hard atheists and government skeptics, abandon their lives to stand in a remote field waiting for a celestial anomaly? To make sense of what happened in the sky that day, you have to look at the ground. Portugal in 1917 was a nation fractured by political chaos and immense trauma, driving its people to look upward for any sign of hope. Following the Revolution of 1910, the newly formed Portuguese First Republic launched an aggressive campaign to erase religion from public life. The state seized church property, closed seminaries, and banned priests from the streets. On top of this internal suppression, the country was dragged into World War I. Thousands of Portugal's young men were slaughtered in the mud of the Western Front. Back home, the economy was collapsing. Bread riots broke out in the cities. The predominantly Catholic, rural population was starving and felt completely alienated by a hostile state. The First Republic had created a dangerous vacuum of hope. The entire country was a powder keg of social despair, waiting for a single spark. That spark arrived in May 1917 through 3 young shepherds from the village of Fatima, 10-year-old Lucia and her younger cousins Francisco and Jacinta. They claimed they saw a woman made of light standing over a small oak tree. The glowing figure asked them to return to that exact spot, the Cova da Iria, on the 13th day of every month. As word spread, the monthly crowds grew exponentially. This terrified the secular government, who viewed the gatherings as a direct political threat. In August, a local administrator intercepted the children and locked them in a jail. The state used extreme tactics to force a retraction. Officials interrogated the children and even threatened them with death by boiling oil if they didn't admit the visions were a hoax. But the children refused to back down. By deploying violent state force against 3 peasant children, the government accidentally validated them. Instead of crushing a local rumor, they turned the shepherds into national martyrs. During these visitations, the entity entrusted the children with 3 secrets. The first was a terrifying, visceral vision of hell. The second warned that while the current world war would end, a second, far worse global conflict would break out, specifically citing the spread of Russia's errors. The third secret was kept under lock and key at the Vatican for decades. When it was finally released, it described an apocalyptic vision of a bishop dressed in white, climbing a ruined mountain, where he is executed by soldiers. To prove the reality of these grim prophecies, the entity promised a massive public miracle on October 13th, which brings us back to that muddy field. After the sun finished its erratic 10-minute dance and returned to its normal place in the sky, witnesses discovered something completely inexplicable. Their soaking wet clothes and the deep flooded mud they were standing in were instantaneously dry. These physical anomalies, witnessed by hostile journalists and thousands of bystanders, made it impossible to simply write the event off as mass hallucination. Skeptics were suddenly forced to grapple seriously with the geopolitical warnings the children delivered. The immediate aftermath for the children was tragic. Within 3 years, both Francisco and Jacinta died in the Spanish flu pandemic. Only Lucia survived, entering a convent where she lived to be 97. For Portugal, the miracle of the sun was a catalyst. It mobilized a deeply silenced Catholic majority, accelerating the complete political collapse of the anti-clerical First Republic. From the ashes of the Republic rose the Estado Novo, an authoritarian regime led by Antonio Salazar. Salazar actively co-opted the Fatima narrative, embedding the Catholic revival into his state to ensure his own political legitimacy. A localized spiritual event in a remote pasture was weaponized by the state. The devotion of the masses became the foundation for a conservative dictatorship that lasted for decades. This map tracks the geopolitical reality after World War II. As the creeping expansion of Soviet influence moved across Europe, the 1917 prophecy about Russia spreading her errors took on a terrifyingly accurate new meaning. Because of this geopolitical alignment, the message of Fatima outgrew Portugal. It transformed into a massive global anti-communist movement, with groups like the Blue Army praying for the containment of Soviet power. Then, on May 13, 1981, the exact anniversary of the very first apparition, a gunman shot Pope John Paul II in St. Peter's Square. The Pope survived the attack. He believed that Our Lady of Fatima had guided the bullet away from his vital organs, fulfilling the vision of the bishop in white being struck down. In gratitude, he enshrined the assassin's bullet directly into the crown of the Fatima statue. Whether you view the events in that Portuguese field through the lens of divine intervention, mass psychology, or unexplained meteorology, the outcome is the same. The children of Fatima delivered a message that actively shaped the political and cultural trajectory of the 20th century.